today we have a special guest from Esperanto Technologies, Jin Kim.
For the last about 10 years, I've been focusing on getting back into the data science and AI field. Let's figure out what software can run on this, then figure out what problems we can solve. It's because of this lack of standards. So one thing we hope to do at Esperanto, at least I have to do, is to contribute to standardization.
And that's a unique opportunity actually,
yes,
that RISC-V opened for everybody.
Yeah.
Hi there, this is Tanya Dadasheva with Almaz Capital, and today we have a special guest from Esperanto Technologies, Jin Kim, who is Chief Data Scientist and VP of Software at Esperanto Technologies.
Thank you very much. Good day. It's a pleasure and an honor to be here chatting with you.
Thank you for coming. And let's start with the discussion. How did you end up at Esperanto? Why did you decide to join?
Sure. When I started out doing my PhD work, and initially I was in academia as a professor, my focus was in artificial intelligence. So I always had a passion for artificial intelligence, but I'm also old enough to have gone through several of the AI winters when artificial intelligence overpromised and underdelivered in the past. But my passion for AI has stayed. The last few years, especially with the emergence of machine learning technology and specifically deep learning technology, AI for the first time is making real impact, economic impact, social impact in a positive way. So for the last about 10 years, I've been focusing on getting back into the data science and AI field. And part of it is personal. It's been a lifelong passion of mine. So I wanted to help companies and organizations be successful from any angle, whether it's from the investment side, technology side, marketing side. So I've known some of the people on the technology side of Esperanto. I saw that Esperanto, I've been following Esperanto for about the last 3.5 years. I saw they had a very innovative approach to doing AI, in particular because of the fact that they relied on RISC-V technology. And I saw that RISC-V as a technology, both in terms of the ecosystem out there, has an opportunity to impact not just AI, but other domains as well, especially in the edge domain. And that's where, if you look at real AI, not research AI, gets applied. There's a lot of fusion of AI technology with traditional technology. And I thought because of the Esperanto's approach to solving the AI computer acceleration problem, it was uniquely positioned to cross the chasm between AI side and non-AI side, and it was an exciting opportunity. So, and that on top of the fact that I've known people in Esperanto, knew some people in Almaz like Jeff, so it was a great opportunity to help change the world.
Yeah, absolutely. And this is interesting because AI can mean a lot of different things, and even if you choose to contribute to it, there are ways to contribute on the application side, on all the layers in between, on the system architecture level. And actually Esperanto is kind of the lowest level possible because it's integrating it in the chip and doing special architecture. And not really actually special, but very much applicable for AI.
Yes.
But with RISC-V and everything that's happening, we have been seeing that software plays the most important thing. So you can do the best chip design, you can have the most efficient, the most productive, but it all comes to software, and that's something we see in the RISC-V community is struggling to get. So what's your view on that?
Well, I think that's a very insightful view. I think it goes down to even the basic premise of we need to solve problems. We can't just develop technology for the sake of developing technology. In AI, in the past, I've done that as an academician, and ultimately, value of technology is what real-world problem we solve economically, socially, politically. And what I mean by that is that a solution to a business problem consists of hardware and software. If you just blindly build a technology, it's hard to productize that is a viably useful artifact. I think the better way to do it is basically look at the business problem that cannot be solved or cannot be solved effectively with current technology, and where the AI technology is uniquely positioned to solve those problems, like early advances in language processing, early advances in vision, recommendation, spatial analysis. These are domains where traditional compute technology has not been that successful because it requires a different way of solving, because you cannot, because of the amount of design space involved, it's very difficult to algorithmically program these solutions. So these are domain, and you have to drill down deeper into specific problem. But once you understand the problem domain, then you can kind of look at what is the software architecture necessary to deliver a solution, because ultimately that's what people see, software. They don't see the hardware. The hardware is just a thing underneath all the software. And I think then based on that, you go and see, okay, if this is the software architecture that will solve this problem, then you can go and look at what are the key parts of software we need to accelerate with hardware that gives us unique advantage or gives unique ability to solve this problem. And then you go and design the hardware. And I think Esperanto is one of the few companies that, maybe not by design, but the net result is that's the approach they took. A lot of the first generation AI compute companies were started by hardware people. And they kind of did it the other way around. They said,
this is the best hardware.
Yes, we had the limits of the Moore's law. So we are in the world era of application-specific architecture. So let's go come up with a cool architecture. Then afterwards, let's figure out what software can run on this. Then figure out what problems we can solve. So you run into this classic problem of developing a technology and trying to figure out what is good for. Okay.
And usually it means that they are good for a lot of things, but not the best for the things.
Exactly. But I thought, as I said, either by design or by circumstance, Esperanto kind of took the right approach. I was saying, well, the key decisions that they made was reliance on RISC-V, because that required having to leverage existing software ecosystem. So that allowed them to focus a lot on, okay, what type of workloads in AI that this architecture particularly good for, and vice versa. And that allowed them to zero in on the recommendation workload at the data center. And that was a underserved market. It was shocking to me coming in from the being in the AI space. Although some of the early successes on AI technology was in language processing and vision, in reality, if you look at data center operations, 70 to 80% of the workload in AI is actually recommendation. And recommendation models, just by the nature of the data they need to process, require very different type of compute support than vision and language processing. So the solution that works for vision doesn't work for recommendation. And Esperanto was one of the first companies to really say, hey, here's a problem. We have a software that is good for this kind of general purpose workload that we can specialize on. Then they develop an architecture that fundamentally uses general purpose processors, but in a novel architectural way with specific machine learning instruction extensions. And I thought that was a cool way of solving this problem.
Yeah, and it basically allows to just be good for all the general purpose use cases, but it also, since again, Esperanto was working with potential clients very early on, before they went, like, way before tape out. So they were looking at the largest clients who have been dealing with recommendational systems, and they had this input of how the product should look like, not even how the chip should look like, but the whole with the system software stack and adopting all the acceleration for compiler acceleration and everything. So I think it's was included in the DNA of the company early on.
Right. I think that's another great point. I mean, I think common misperception from people coming from outside the AI field is that you have all these AI models, ResNet, ResNet, BERT models, and so on, different kind of model
all
architectures.
All the known benchmarks,
Yes. And a lot of people naively think, oh, so if this thing can run, this model is good. And the reality is that in real production use cases, applications invoke models as part of the process, and as a result, a typical application, whether it's in vision or recommendation, you're not invoking a single model, but you invoke a chain of models to solve a particular problem. Simple example is you see a lot of these facial recognition as a thing. In order to do facial recognition, you have to first detect there is a face. So you invoke a object detection model. Then object detection model produces lots of false positives. So you have to actually decide which of those bounding boxes you really want to analyze. And there's an algorithm called maximal suppression, and it's a non-machine learning algorithm. Then after you do that, then you do facial classification algorithm. And this is a very simple example, but it shows that application is to invoke a number of different models. You go to automotive system, and it's very complex. You're talking about invoking a series of anywhere from 6 to 20 models just to do localization and decision making on what route to take. You go to recommendation model, is you don't invoke same one model. Some query batches have a lot of simple instances, so you want to use a shallow model early on, then go into a deeper model that's more compute intensive. And in each of these cases, it isn't just pure machine learning workload, but there's also a lot of non-machine learning workload involved. And an architecture like the Esperanto that has general purpose processing cores where you can run both machine learning workload and non-machine learning workload together. So one of the characterization of real workload rather than just research is that whether it's in recommendation or vision, typical workload has machine learning component, but it also has a lot of non-machine learning component. And if you have a very specialized architecture that's only good for like tensor manipulation associated with machine learning, then a lot of the work, the non-machine learning workload that's typical of an application has to be done on the host computer side. That creates natural bottlenecks that a lot of people look at. One of the appealing things about the Esperanto's architecture, because of this, their use of general RISC-V instruction set with extensions for machine learning, you can run both the machine learning and non-machine learning workload on the same processors. And that is very appealing because you have one of the growing emergence of AI use cases is in information fusion or sensor fusion. Everything from automotive system to robotics to manufacturing, anything dealing with sensors requires information fusion. And one of the emerging model architectures that's very effective for information fusion is something called the transform architecture, where a lot of the language processing models are based. But transform architecture is a basic for implementing an autoencoder structure for translating data in one domain to another domain, like language translation, right? But also from vision to image data to vector data, for example, for processing. It's very effective. And sensor or information fusion requires a lot of non-machine learning workload and machine learning workload to be executed concurrently. And if you have a homogeneous architecture like Esperanto, it gives you, as a system architect, greater flexibility on more effective utilization so that you don't have inter-processor or processor memory bottlenecks to emerge. It's a more flexible general purpose architecture. And that's also very important because AI is a very rapidly changing field. 5 years ago, 6 years ago, when deep learning started to emerge, there were maybe like 200-300 unique architectures. Now, as of like last year, we are talking about 4,000 and growing architecture, different algorithms. And if you have a hardware architecture that is good at doing particular model architecture, it rapidly gets outdated. So it's important that the general purpose architecture instruction set with extension that is scalable, not just scale up, but scale out architecture.
But I think it's also interesting to think about this in terms of where all these algorithms are run, because it can be different. So when we talk about hyperscalers, of course the hyperscalers need something repeatable and scalable fast. That's how like x86 won a long time ago. But I think for them it's one thing, but if we talk other use cases and when we talk how the also transform models or like not necessarily those huge models with multiple billion parameters work, they don't have, they require different kind of architectures in different places, and it all comes up to infrastructure in different domains, I think.
Agreed. And I think AI technology is still emerging, developing. We are still heavily reliant on we train the model in the form of supervised learning, that requires a lot of labeled data. We have made great advances in automated way of labeling data. But as long as you rely on data labeling and supervised method of developing models, there are some domains you can't get into, especially where not a lot of data is available. So AI also has made great progress in semi-supervised or self-supervised learning approaches where you don't need as much labeling. But that also requires much greater compute resources. Okay, like in robotics and automotive systems, you can't possibly learn every situation, so you have to be able to dynamically learn. And I think Esperanto's core architecture allows you to be flexible and scale out, and I think it has applicability beyond immediate business target. Our immediate business target is recommendation workload inference on data center, but I see tremendous opportunity in edge inference, and that's where I think that's one of my interests is in just expanding out the RISC-V software ecosystem for AI based on my experience too, so that we can cultivate partnerships, so we can go using this technology, work with partners in different market spaces.
But that also requires adaptation of all the instruments. How
Yes.
machine learning operations, so machine learning ops, how do they look for edge?
Mm-hmm.
It's completely different than for the just usual environments of the cloud.
Exactly. So it's a challenge. I mean, I like to think of myself, having been an old professor, I'm constantly learning, and I think that also goes to the company as well. We have to be humble enough to know that where our technology has value, and contribute to the open source community. So we are constantly building up this repository of knowledge, and RISC-V is a great open source community for doing that. Even our implementation of our first product follows the OCP guidelines. So we support the Open Compute Foundation initiative. So that again, I think the community aspects where we can share some elements of the technology and build out common APIs for different software and hardware to work together will continue to spur the growth of this field.
Yeah, actually, what we saw a bit at RISC-V, that hardware innovation now is a bit faster than software.
Yes.
So there is a lot of new companies emerging,
Yes.
variety of architectures, variety of new chips. But software is not adopting fast enough for now in terms of just managing all of this and everything. So do you see this?
It is a challenge. I think, by the way, as much as I agree, you shouldn't let software people hear that. They'll immediately go, no, that's not true.
Yeah, absolutely. No, of course. But that's their job, of course.
But here's a reality. I mean, if I look at last year's data, only about 23% of AI projects in the industry went into production.
Yeah.
So you have to ask, as a data scientist, what is preventing more of these projects from becoming production quality? If you look at other software technologies, it's 92% or higher goes into production. A lot of it is that it is still a new field, whereas you have mature DevOps capabilities in the traditional software engineering. The machine learning ops is still a new field, it's emerging. How people collect, manage data-driven, but this relies on big data technology. It's still growing. There's a lack of standards, so there's a lack of collaboration going on. We have some brain drain from academia to industry because a lot of companies are pouring huge amount of money to get talented professors out. So a lot of my colleagues who's been in the industry in a while are going back to academia. Even my old university, Carnegie Mellon, has reached out to me and saying, hey, are you going to come back? And I was saying, probably one of these days. But I think it is a challenge. I think the lack of advancement in software side is mainly because of, in the AI side, it's because of this lack of standards. So one thing we hope to do at Esperanto, at least I hope to do, is to contribute to standardization. I think more common interface and standards we have, it helps us as a business because it helps us attract partners, but it also helps rapid advancement of the field as well.
But standards, you mean not necessarily even like technological open source standards, but maybe methodology standards?
Methodology standards, general, just even simple thing as an API standard.
Yeah.
Okay. That I think would be good. And also, at some point, once Esperanto is larger, we need to contribute back to the society. Work with universities, do joint effort with university research centers. So we transfer some knowledge back as well.
Yeah, but universities are a great part of all the open source communities. They're like centers of innovation for that.
Exactly. So
I think it makes sense, of course. Yeah. So, and by the way, what in terms of thinking machine learning use cases, what do you think is like the driving force of this innovation right now? So there is a lot, of course, happening, like we mentioned, recommendational systems,
right.
image analytics. But what do you think actually drives the adoption of new hardware easier?
I think one of the challenges is that although the spotlight is on the front-end applications like vision and language processing, I think the real innovation is coming in the back offices. This is where like the recommendation example, back offices, loan origination that tremendously increases productivity. There was a case study done by, I forgot if it was Chase Bank or Citibank in US that adapted AI application for loan processing, just simple processing steps. So it's just a natural language processing. They were able to process something like, if I remember right, something like 30 to 50,000 loans in less than a day. That will take the existing manpower several months to do. Net result, they're able to deliver better quality of service to their customers. It led to lower number of fraudulent cases for banks, so it reduces their cost. Net result is that it created a better banking service from the retail side. So there are a lot of other cases like that, use cases and back office use cases like grocery. There are a lot of companies struggling to manage SKU movement within a store,
Logistics,
everything from like fruit quality, hey, that fruit looks bad. Those are things that AI is very good at, just looking at cameras forever and saying movement of objects.
But that's a whole lot of combination of different models, as you described previous use cases.
Yes.
I think this one's involved even more. So it's
but it has real value. There's a lot of people.
Absolutely.
I mean, my sister is an oncologist in dermatology, and she is very excited at the prospect of the cell phones. I understand in skin cancer, early diagnosis is very important. Your cure rate is dramatically high, but later if you can't diagnose it later on, it's hard to cure. So just using those cell phones to just take a picture of skin, and even if it generates a lot of false positives, if it says, hey, go see your doctor, that can lead to additional diagnosis. In a lot of the developing countries, consumption of health is much more limited. So even if you can deliver limited health to the edge using AI technology on cell phone, which is kind of ubiquitous at this point, I think that improves the quality of life. I think those are some of the things in healthcare, back office automation, supply chain, water distribution. You're in California, you know how we are going through droughts and so on. But better management of our water resource, just reservoir, where to allocate waters, that can be done through machine learning technology efficiently. Those are, I think, areas where there are a lot of use cases that doesn't get the glamour of speech or vision, facial recognition, but I think that's where the real benefit of AI technology comes.
And then the question is, what are the barriers in those? Because the one thing, because it's all different industries, one thing that I can think about is different infrastructures. Mm-hmm. So it's basically someone should provide the service and understand how to build this whole infrastructure of all the moving parts with all the system level software down to the hardware level.
Right.
So there should be like somebody understanding this well enough. And then if we talk about like developing countries, it's also the question of who can provide that
exactly.
and the service that as well.
And some of it is just pure economic dynamics, right? How the value changes. I mean, I think the recent COVID issue, and I think we're living in a post-COVID world, is a very different world. As I saw the other day, I was seeing on one of the news sites, interesting phenomenon with restaurants in U.S. In U.S., one of the industry segment that was hardest hit was the service industry. They can't hire enough waiters and bartenders now at this point. So a lot of restaurants are struggling as they open up again. So what are they doing? Suddenly, the robot technology for delivering food, which was not economically interesting 1 year ago,
for sure, it was,
suddenly is economically interesting because they can do more with it's less people, and they're not taking any jobs away because no one is applying for these jobs anyway. But even a simple rudimentary AI technology of navigating between tables and delivering food to the tables is
I mean, that's not that complicated.
And it only became viable because of the change in economic dynamics. I think same thing is happening in some of the other industry segments. I mean, Boston Robotics, famous for their dancing robots and walking robots. I mean, the technology is proven enough and cost-effective enough that you can now think about those traversing robot in unusual applications. Simple thing as security patrol, which was not economically feasible. I can see why Tesla is interested in building a robot in the future. I don't know if the ambitious plan is doable or not, but it does open up new opportunity. I think change in economics affected. From an AI technology, the biggest challenge is, do we have enough data? As I said, the current AI technology still relies too much on supervised learning, and that requires heavily on labeled data.
So it sounds actually very interesting. And the next question is, with all the variety of architectures, all the variety of hardware, all the variety of models and the combination of models, the question is how to make it all compatible, how to, so the robot developed by Boston Dynamics or Tesla or something that hyperscaler builds for themselves, how it's all gets compatible in terms of not just software levels, but architecture levels, software levels, hardware levels. So is there like standards developed, like with International Space Station? So everybody develops something of their own, but it's all combinable and compatible. And
correct. I think as we know, the automotive industry really took off because people had replaceable parts. Everybody made parts to the same standards, so you can use parts from multiple vendors and so on. AI technology, we've been trying to do that from an academic point of view, and many of the companies as well. What I mean by that is that rather than, as you pointed out, one of the biggest challenge of a hardware company is lack of software. So if we can develop a software tool chain that is standard with open APIs, and all hardware vendors have to do is go support that. Much like how you would program on an Intel CPU, you can make, as long as you clone it, support the same API, you can run the same code on Intel x86 architecture as well as AMD x80 architecture. Okay, same thing for ARM, same thing for RISC-V. You're developing standard interfaces. So any software that supported interface, your hardware vendors can support. It makes the job of the hardware vendor a lot easier. It also makes the job of the software vendor a lot easier because you don't have to worry about specific hardware. You can design to a standard, then it should run on any hardware that supports that standard. That's the direction AI is moving, but in some ways a little too slowly. We still don't have quite that level of standardization yet. I mean, some early efforts were made in standardizing at the framework level. So you have things like TensorFlow, PyTorch, as machine learning frameworks that's been standardized. You have some optimization tools, especially in training is different, in inference to where we are. You have to optimize the model before you can run it. So you have things like open source initiatives like Glow and TPM, which Esperanto support both, that allows you to take a standard up way of optimizing a model for a specific target architecture. But challenge is that after that, you have to do your own. Every vendor has to do your own. The standards don't quite exist like an Intel. So I think as I keep going back to this RISC-V, passion for RISC-V, I think the reason I got attracted to Esperanto and RISC-V is because RISC-V offers this opportunity to come up with this, define this standard ecosystem and API from all the way from hardware space to application space. I'm hoping that'll enable broad adaptance and it's much simpler way of developing product for the space.
Yeah, that's a belief, and that's a unique opportunity actually that RISC-V opened for everybody. Yeah, thank you so
really
much for sharing it.
My pleasure.
Was great discussion.
Great working with Almaz, and thank you, Tanya.
Absolutely, thank you.